All right, so we talked about parabolas before. And so when we talked about parabolas previously and we graphed them, we didn't do all the completing the square and everything that we wanted to when we were trying to write this in vertex form. We just used factoring and solving by factoring to be able to find some different intercepts and stuff. All right, so we're going to do more with parabolas. So your kind of generic equation looks like this. And so what you want to remember is that in all of our graphs that we've ever done, the A value just tells you if you are opening up the same way as the parent graph or if you have to reflect. So in this case, if your A value is a positive value, you're going to open upward this way. And what that's going to do is it's going to create a minimum down here at your vertex. And if your A value is negative, it's going to open up the opposite direction. And it's going to create a maximum at its vertex. So other little things to remember is that when you're making an in-out table, right, and you've got your x's and your y's, that your h value is the only thing that affects the horizontal shift. So you're going to be either adding or subtracting that h value based off of the sign on the inside. So it's always the opposite of what you see. And then everything else affects the y. So because you would have to order of operations do this work before you multiply, so then you would multiply by your a value and then add your k. Let's see, other little things. Your vertex itself is located at HK. You have a line of symmetry which cuts your graph in exactly 2 equal pieces. And that's the line that runs right here through the vertex and makes a mirror image. And so that's an invisible vertical line at x equals h. And then if you are asked any information about a shift, right, you have your horizontal. And that is based off of the h value. And remember, it's always the opposite of what it's currently sitting there. And so that's going to be a left or right. And you need to use the words left or right. And then you've also got your vertical shift, which is based off of your k value, and that's going to be up or down. So when you have an equation that looks like this with parabolas, that's called vertex form because you can quickly identify the vertex. And so what we're going to do is we're going to do some graphing and also some completing the square to write our equations in vertex form. Right. So let's just do some completing the square. Bless you. All right, so on here, all I want to do for this first one is just complete the square and then identify some information. I'm not going to actually graph this one. So when you complete the square, and you, when we were doing this yesterday, you added something to be able to write a binomial square. So it was kind of like we only had those 2 terms, and we were adding something. Well, you can't just add something to an equation and have it still have the same value. If I want this to have the same value, when I add, I also have to subtract. Right? So what we're going to do is we are going to isolate our 2 terms with the variables. We're going to say I want to be able to add something to this to create a trinomial that is going to be a perfect square. But because I'm going to add something, I also need to subtract so that way I keep my equation balanced. And whatever happens over here is going to combine with my constant. So your constant, you're going to just take it and you're just going to hold on to it. Just push it off to the side. And that constant right there is part of the k value. It's not the entire k value, it's only part of it. The other part comes from what happens when I try to complete the square. All right? And so what I just want you to be able to see is that if I add and subtract the same thing, that's only still going to give me the same three terms that I started with. Right? So if I take this number and I cut it in half, right, and then I square it, that's what I'm going to have to add to be able to create the binomial square. So that's what I also have to subtract to keep my equation balanced. Right. So you can see if I'm adding and subtracting the same thing, they cancel each other out. All right, but now I can actually write this as x minus 3 quantity squared. And these two are going to add together to be a k value. And so I'm going to get minus 16. And so your equation looks different when it's in vertex form. But if I asked you to like multiply all of this out and combine your like terms, you'll end up being able to work your way backwards to the original. And so now I could say my vertex is the coordinate 3 and negative 16. And then my line of symmetry is just x equals 3. And so that's going to be the plan when we're doing some completing the square. I'm going to do an example for you where you have to go through all of the process of graphing after you've already got something into that vertex form. And then we're going to go back to some completing the squares in a minute. So for this example, I am going to have to graph. But I'm going to graph the equation. So y equals x minus 3 squared plus 4. Now this one's already in vertex form, so I don't want to do anything to it. I just want to start identifying some information. So your vertex is the coordinate 3, 4. Which means my line of symmetry is going to be at x equals 3. And that's again that it goes through the vertex to cut this in half. And I just want to identify what my shifts are. And so based off my vertex, that's going to tell me how my graph is going to shift. Because a general quadratic starts at the origin 0, 0. So that means that this is going to move to the right by 3 and then up 4. And so what that's going to do is that's going to help me to create my in-out table. All right, so in a normal in-out table, you're looking at using the parent graph where y is going to be x squared. And so we're going to use things like, negative 3, negative 2. All right, so we're going to be using all of the integer values. And so if I square all of my integer values, I'm going to get positive values when I substitute these x values in and square them. And this one right here is your vertex. You can see it's the point that as you start moving outwardly from it, I have a balance. Now on most graphs, you're not going to be graphing all of those coordinates. At the bare minimum, you need to graph the 3 in the middle, the vertex, and one on either side of it. If your graph will hold more points, then you'll start using the ones as you move outwardly for however many your graph can hold. All right, but you need at least 3. So if that's my parent graph, then I'm going to have to take all of these x values and add 3, and the y values and add 4 to figure out where my new coordinates are going to go. And so what I'm going to do is I'm going to make a new chart down here. Right? So that way I can figure out what those are. And so I'm going to start with these three. Right? So if I just take -1 and substitute in for x, I get -1 plus 3, right? Which is 2. 0 plus 3 is 3, and 1 plus 3 is 4. So I'll hold off on the other ones until I see if I need them. So I'm just going to focus on these right now. And the same thing, 1 plus 4 is 5, 0 plus 4 is 4, and 1 plus 4 is 5 again. And so the reason why I'm only going to stick with these three right now is because the assignment that you're going to work on, the graphs you have are only 6 by 6 graphs. So I'm not going to make a chart bigger than that for our examples either. So I'm going to hold off on those. So now I'm going to make my graph. All right. So I need to be able to make a graph that'll include those 3 points. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. And I'm not even going to bother with the other parts to the graph, the other parts of the axes, because all of these, there's no negatives in here, so I don't have to worry about the other sides of my axes. All right, so again, here's my vertex. And I'm going to plot those points. All right, so the first thing I'm going to do also is I'm going to add my line of symmetry onto my graph, so that way I can make sure that when I graph that I keep both sides of that balanced. And my coordinate 3, 4 needs to be on that point, or on that line. And then I move outwardly. I have 2, 5 as a coordinate, right, and 4, 5. And so again, as long as those 3 are my bare minimums, I can make my graph.